Hey guys, and welcome back to the second episode of the Inventory 2024 tutorial series. In the last episode, we set up this user interface with the armor inventory, the hotbar information, etc. In this episode, we're going to be importing some modules that I'll be using in the system, and I'll go through how those work and what we use those for. And we're also going to work on some server-side setup for the inventory system. Without further ado, let's get started. So the first thing I'm going to do is disable some of this UI so we can see what we're doing a little bit better. I'm going to select inventory and just make this whole thing invisible. Then I'm going to select this error message and make this invisible as well. Okay, so the first thing we're going to do is import some modules. Two modules, in fact. There's the signal module and then there's the janitor module. So we're going to go over to replicated storage. I'm going to press plus, create a new folder. I'm going to rename this folder modules. And inside this, we first want to download the module files themselves. And there's going to be a link in the description. So you can either go to the dev forum page, which is right here, and you can download them right here. It's two different files. They're Roblox model files. Or you can go to the Discord server and find them in the Nines modules channel. Either way, it should be the same file. So then download these, and once you've downloaded those, head back into Roblox Studio, right-click on this modules folder and click Insert from File. Navigate to wherever those modules are. There's this one right here, the signal module and the janitor module. So let's look at the signal module first. Neither of these modules are entirely necessary for this system, but the reason I'm using them is because it saves a lot of time, and I also wanted to kind of introduce people to modules like these, not necessarily these specific ones, because they can save a lot of time in the development flow of like an entire project, for example. So the signal module is essentially an alternative, or essentially like an automated version of using remote events. It's a module script that you can require from both the client and the server, hence why it's in replicated storage, which can be seen both by the client and the server. When it's required by the server, it comes down here. These are all just functions. We'll go over these in a second. It comes down here to the very bottom, right here. It checks if it's the server, and then it creates a single remote event, a single remote function, and a unreliable remote event, which is a new thing that Roblox added. And it connects to the on-server event, on-server invoke, and on-server event for all three of those. And what it does is when the client requires it, it finds those three values and connects to them on the client as well. And then it uses these functions in place of actually manually accessing these remote events and remote functions. It uses these functions in order to essentially automate the process of creating or of sending signals from one location to another, for example. So rather than having to, say you had like a special ability, right? Say it was like a fireball ability, right? And you wanted the user to be able to press the E key in order to shoot a fireball to where the mouse is, right? Normally you'd need to get the input from the client side using user input service, and then you create a new remote event in replicated storage or somewhere else where both client and server could see it, and then the client side would fire the server side in order to send a message to the server to then shoot the fireball and create all the visual effects and whatnot. The useful thing about the signal module is you don't have to create additional remote events. This creates a single remote event and remote function, and it uses that same remote event, remote function, and unreliable remote event for every single signal that's fired. And it just uses if statements, essentially. Using this, you can specify a key, and it differentiates which function to run based on the key that's provided. So if you use one of these listen functions, so if I minimize all this, there's these listen functions. There's the plain listen, which I'll go over that in a second. First, there's the listen remote. That would be, essentially, if you're on the client, listen remote is going to listen to signal fires from the server, invoke being the remote function version, and fire being the remote event version. So listen remote is going to listen to the other side. So if you're on the client, it's going to listen to the server. If you're on the server, it's going to listen to the client. Listen bindable is going to listen to the same side. It's named bindable after bindable events and bindable functions. And so bindable, if you're on the server, it's going to listen to the server only, and if you're on the client, it's going to listen to the client only. But if you want to listen to both of them and not discriminate between the two, then listen will do both of these. And there's a bunch of other functions. I think the primary ones we're going to be using are just fire client, fire server. I don't know if we'll be using fire client or not, but it works essentially the same as a regular remote event. It makes it a little easier where you don't have to actually create the remote events, and you can just specify a string key and then just make sure that's the same between the client and the server that are communicating with each other. So now moving on to the janitor module. This module is similar to a lot of other modules I've seen called like maid or whatever, but I call it a janitor just to be, less sexist. But anyway, the basic idea of this module is that you can create this new janitor object using janitor.new. It has a table right here, the self.chores. It's an empty table, and if you run this give chore function, you can put something in that table, and then when you run clean chores, it'll loop through all those chores and essentially do those chores. What it means to do the chore depends on the type of object that you provide. So if you provide a Roblox script connection, so like you do uis.input_began:connect, that would return a Roblox script connection. Then if you put that into the janitor using the give chore function, if you put that as the chore, then whenever you run janitor.clean, it will disconnect that connection. And if it's a tween, it'll cancel it. If it's a function, it'll run the function. If it's an animation track, then it'll stop the animation. And otherwise, it'll attempt to run :destroy on it. So if there's a function on the object called destroy, it'll run that function. Otherwise, it won't, and it'll just be confused. And I'll give this warning right here. And the reason I did it this way, instead of checking if it's an instance, because all instances have this destroy method, the reason I didn't specify that it's an instance is because then you can create your own custom object type using object-oriented programming, and you can implement your own destroy function, and then this janitor will work with your object in order to destroy it if you add your object to the janitor's chores. But anyway, the purpose of this module is going to be to just make it easier to clean up loose ends and make sure there's no memory leaks, because normally if you had a bunch of events you needed to disconnect and objects you needed to destroy, then you'd have to go through and do each of those things one by one and make sure you don't have any loose ends. And it's easy to miss a thing here or miss a thing there. But with this janitor function, or with this janitor object, if you create a new janitor, anytime you're doing something where you're going to have to do some cleanup work at the end, you can add your cleanup work to the janitor module or to the janitor object as you go, and then you can run it and just do it all at once rather than having to worry about making sure you didn't miss any loose ends, because you can just do it as you go. Alright, now let's get started with the actual inventory system now. So the first thing we're going to do in order to set up the server side, because a lot of the client side is going to be based on displaying the inventory, displaying the items, before we set that up we need to make sure we actually have the items registered and set up in the inventory system. So we're going to work on the background stuff that's on the server side. So we're going to go to server script service, click plus, create a new regular script. We're going to rename it to server. I'm going to use somewhat of you wouldn't call it a framework, but a way of organizing these scripts where there's only going to be one server script and one client script, and then there's going to be modules inside of these. So that way, if you were to start your own game or whatever with this project, you could expand on it by adding more modules. So I'm going to add a module in here, module script, and we're going to call this one inventory server. And so if you wanted to add, say, a shop system, you could add another module in here and call it shop server, right? And you could do that for any other system you needed to add in the server or on the client. We're also going to go to starter player scripts, and add a local script, and we're going to name this one client. And this is going to be similar to the server side. We're going to add a module script, but this time we're going to call it inventory client in order to differentiate it from this one. And this is going to handle all of our client-sided code. So let's close out these ones for now. We're going to ignore the client side for now. I'll get back to that side later. And we're going to go over to the server script. I'm also going to go in here and remove this so we're not having that print all the time. So we go into the server script. All we're going to do is we're going to require this module script right here. So we can do that by defining a variable and then using this global require function, parentheses, and then put the path to the module script. So in this case, it's going to be script.inventoryServer because it's right inside the server script. In this module, I'm going to get rid of all this, and we're going to define local inventory server, set that to an empty table, and then we're going to return inventory server. So it's essentially the same as it was by default, but we just renamed it. And then we're going to add a start function inside of this table. And then press enter to add the end, and there we go. So now this is just an empty table with a function called start, and this is also just an empty function. So we're going to go back to the server script and do inventory server dot start, and we're going to run the start function. And that's essentially going to run any code that we need to run right at the beginning of the game. So we can close this out because that's all we need in this script. We're going to do all of our work in this inventory server module script. So the first thing we're going to do is we're going to set up the player added event, because we're going to need to track when a player joins the game. So I'm going to add a section for that. we're going to loop through all the players in the game. So before we can do that, we need to define the player service. Then we're going to do for I, comma player, and we may as well use type definitions. So we're going to define this as a player object. For I, comma player, in players, get players, do. So this is going to loop through all of the players in the game that are currently in the game. We're also going to need an actual function to run. So player added function on player added player. We're also going to define the type here, just so it helps with like auto-completing, and it also keeps it clear in the code what type of object each variable is. So now we're going to go in here, we're going to run this on player added function. But we want to make sure we run it using a test.spawn rather than just running it normally, in case this function ever has a delay in it. Because if there's a bunch of players that happen to join right at the same time and it loops through all those players, then we want to make sure that one player joining doesn't like interfere with the other one by having a delay in here. So we're going to do task.spawn. So we're going to need the first argument of task.spawn is going to be the function to run. So it's going to be inventory server.onPlayerAdded. And then we just need to do comma player, and that'll put this will be the argument into this function. So that will run the function with this as the argument. And the task.spawn is going to essentially run this function on a separate thread. Say there's two players we're looping through in here, right? The first player, say this has a delay and it has like an infinite while loop or something, then this will run on a separate thread. So even though this running for the first player is going to run indefinitely, then the second player will still be able to run this because the first player's function, the onPlayerAdded, would be running in a separate thread, and it won't interfere with what happens after this line. And then in order to account for new players that join the game, we're going to have to do players.playerAdded connect, and then we can just do inventory server.onPlayerAdded and provide the function. And that will make so anytime a new player joins, then it'll run this function for that player. In order to test this, we can add a little print. So print player.name join the game. Then if we hit play, go to the output window, we can see it says 1919 join the game. You can also see we have all these still. Alright, so on top of the player added, we're also going to want player removing, which is when a player leaves the game. So we're going to define a function for that as well. I'm going to add a print test here as well. Print player.name left the game. Player removing. Players.player removing connect inventory server.player removing. .onPlayer removing. Okay, so let's test that real quick. So 1919 joined the game. If I press stop, it says I left the game. Cool, we know it works. Can remove those prints, and we're gonna get to what we're gonna do here later. And here we're essentially just gonna say whenever a player leaves the game. We're also gonna use game:bind to close in order to say when a server gets shut down as well, but we'll get to that later. For now, we're gonna go to the onPlayerAdded function. And the first thing we're going to do is, we have this starter pack, and it has all these items. When we press play, it puts those items in our backpack, or like it copies them, and puts a copy of each item into our backpack. Just to make some things easier with this system, before we do anything else, we're going to wait for all of those items to be copied over into our backpack, because that will make things easier later on. So we're going to do waiting for starter pack. We need to define a service up here. Starter pack equals game. Service starter pack. We're going to do a for loop through all of the children in starter pack. Okay, so we're going to loop through all the tools in the starter pack, or all the children in there, while not player.backpack find first child tool.name do task.wait. You could also just do wait like that. The only real difference is that this task.wait can wait for smaller intervals, but it doesn't really matter in this case. Anyway, so what this does is it's going to loop through all of the tools in the starter pack, and for each one it's going to wait until a tool of that name is found in the backpack. This won't be a perfect way to wait for all the starter pack to be loaded, but it should work most of the time. The only case where it might not work is if you had multiple items of the same name, because then even if only one of them is copied over to the player's backpack, then all of them will essentially pass through this, even if they haven't all copied over yet. There's additional checks you can add, but it shouldn't be too big of a deal. So then the next thing we're going to do is we're going to create a new inventory table. So essentially it's going to be the data for the player's inventory, and it's where we're going to be storing all of the information that we'll need to store. Local inventory equals an empty table. We're going to put inventory equals that, hotbar equals that, armor equals that, next stack ID equals 0. And I'm just creating these all as empty tables for now, because we're going to be adding items to these later on, but by default they're going to be empty. I'm also going to define some types in order to help clear up how this inventory is going to be structured. So we're going to go up here, types, type inventory equals empty table, and we're going to say that an inventory is going to have an inventory inside of it, and that's going to be of type table, and each item in the inventory, each item in this table is going to be of its own type, so we're going to do type stack data. And all of this type definition, if you're not familiar with these type definitions, they won't actually impact the code at all, but this is going to help a lot with understanding how the inventory system is set up, as well as, auto completion and things like that. So we're going to go over how this is going to be structured, and then we're going to actually set that up. So each stack is going to be set up with a name property, which is going to be a string, a description property, which is also going to be a string. It's going to be set up with a image property, which is also going to be a string. Item type, string, is droppable, boolean. And then finally items is going to be a table of tools. And then stack ID is going to be a number. So this inventory is going to include stacking, and so rather than listing each item in this inventory table as its own item, we're going to list it as a stack of items with all of these properties. And so this inventory right here is going to be an inventory, is going to be a table of stack datas. So the hotbar is going to be structured as a table as well. It's going to have strings for the keys and numbers for the values. And the armor is going to be structured the exact same way. And then the next stack ID is going to be just a plain number. And so that's what an inventory is going to look like. So each player is going to have its own inventory of this type, and the inventory is going to have all of these things inside of it. So then this is the inventory that we're creating. We're going to define it as an inventory. And now notice I'm going to remove this and retype it out, and you can see something. So look, so if we type inventory, you can see it auto completes because it knows that we have an inventory property for things of type inventory. And of course, then it'll essentially help me autocomplete of a type hotbar. It knows I want this key, set that to an empty table, armor, set that to an empty table, and then next stack ID, set that to 0. And this next stack ID is essentially going to help us define the stack ID property of each stack in order to make sure each stack is unique, because that stack ID is what we're going to use to tell stacks apart, and also it's going to be what we use in the hotbar and the armor in order to define what stacks are equipped to what slots of hotbar and armor. I'm also going to change up how this armor is defined. Type armor. I'm going to be a little bit more specific because it's not just going to be any strings to any numbers, it's going to be specific strings to specific numbers. So we're going to reference our GUI, make sure we're consistent with this. So we have head, chest, and feet. So we're going to do head is going to be a number for the stack ID that's going to be equipped to that slot. Chest, number, feet, number. And while we're at it, so we're going to change this, change it to be of type armor. We're also going to add a type for the hotbar. Slot 1, number. Slot 2, number. And just keep this going. And now, since we're going to have a lot of these type definitions, we already have 4 of them, and we're going to need these in the client side as well, I'm actually going to move these into a separate module. So we're going to go over to replicated storage, modules. We're going to add a new module here. We're going to call this types. And this is where we're going to store all of the types in our project. So we're going to paste what we had over here. Inventory system. These are all the types in the inventory system. We're going to add export before each of these. And that will allow us to import this module and then access these types from the module. So now we're going to go over here, inventory server, we're going to define local rs equals gain to service replicated storage. So that'll give us this. And we're going to do modules, local types equals require rs.modules.types. So now we're here where we define inventory, we're going to change that to types.inventory. And it'll still autocomplete in the same way as before, but now we have all of our types organized in this script, so it's not making this script longer than it needs to be. And so we can also reuse this, since this is in replicated storage, we can also import this from the client and still get the same auto-completion on the client as well as the server. And generally it's a pretty good practice to keep all of your types in the same module script, so that way you don't have to worry about knowing where each type is defined, and if you need a specific type you can just import the types module and you have all of the types. I'm also going to make a couple last second changes. I'm going to add question marks after each of these, and the reason for that is because if you add a question mark after a type definition, then it lets the computer know that there's a chance that this value might be a number, but it also might be nil, which is why there's a question mark there. Because there might be something equipped to slot 1, but it might also just be empty. So we want to make sure we have that clarification in there. So the next thing we do, now that we finally have our inventory set up with all the types and whatnot, we're going to go to inventory server, we're going to add a value inside inventory server, call it all inventories. And we're going to set it to an empty table. So then we're going to do inventory server.allinventories player equals inventory. So then this is going to store the inventory that we just created inside this list of inventories under the player, using the player as the key. So that way if we ever want to access a specific player's inventory, we can just do all inventories and then index it with the player. Okay, the next thing we're going to do is we're going to use this janitor module we imported at the beginning of this episode. So we're going to import that, or we're going to require that in the inventory server module. We can close this out. We're going to create a new value in here, inventory server.janitors, and this is going to be a list, so every player is going to have their own janitor, and like their own instance of a janitor, and those janitors are going to be essentially storing chores that need to be completed whenever the player leaves the game. So that way when the player leaves the game, in order to clean up any loose memory or anything, all we have to do is run the clean method of the janitor, and it'll do all the work for us. So down here in player added, before we create the inventory, I'm going to create a janitor. Local janitor equals janitor.new inventory server.janitors player equals this janitor. And then we're going to give it a chore. And it's just going to be a function that we want it to run whenever the player leaves the game. We're going to do inventory server.janitors player equals nil. And that will essentially remove the last reference to this janitor, because this janitor is going to be stored in here, and that's essentially going to be its primary reference. That'll remove the reference to the janitor object when the player leaves the game, and that way, by removing the reference to it, the garbage collector that Lua has set in place will come through and clear the janitor object from the memory. And so then in player removing, we're going to do inventory server.janitors player clean. Or alternatively, you could even just do destroy, because if you look at the janitor module, so we have a few functions. We have new, and that creates a new janitor, and we have clean, give chore. I also have this clear particle function. This isn't anything fancy, it's a little bonus helper function, but it won't be relevant in this tutorial. And then this destroy function down here, all it does is just runs the clean method. Which the reason I have this here is so that way you could add a janitor to a janitor, then one janitor would trigger the other janitor to do all its chores. And it's useful in object-oriented programming, but in this case you could do either clean or destroy. Either way it does the same thing. But it'll run all of the functions, all the chores that the janitor has stored up, and it'll complete any tasks that we need to complete whenever the player leaves. So before we get too much more carried away with setting some stuff up, I'm going to do a quick little test. And this is it's good to test every now and then just to make sure everything's working correctly so far. So we're going to do print inventory just to see what the inventory looks like. It's going to be empty by default. It's not going to have any of the items in it. We can see it prints a table. If yours doesn't print a table, you can try playing around with these properties up here. I believe there are some configurations that change how that'll change how the tables show up. So if you can't expand it like I can, then play around with those properties. So we have the armor, hotbar, inventory, and next stack ID, and all those are just empty and 0, which is what they should be. So the next thing we're going to do is we're going to do some preparation work for saving and loading. We're not going to set up the saving and loading yet until we actually have the inventory system functional, but we're going to have some functions created so that way it makes it easier to set it up later on. So we're going to create a couple new functions. And we're just going to add some prints in here, or I'll do warn, just so that way it's orange and it pops out. Saving has not been configured yet. Set up yet. Loading has not been set up yet. Now those will just serve as reminders so we don't forget to set up saving and loading later on. And then as for where we're going to run these functions, for one thing we need to run it in the player removing function, so we're going to do inventory server.save data player. So anytime a player leaves, it'll save their data or they'll save their data, so that way they don't lose anything. We're also going to do shut down game find to close, and this is going to be a function that will run whenever the game is shut down. We're going to loop through all the players. And then we're going to do inventory server.save data player. So we're going to save the data of all the players. Then we're also going to do an autosave system, which in order to do this, we're going to have an infinite loop that'll just be running throughout the entire game or throughout the entire server's lifetime. And so, but we don't want that to interfere with anything else, because if it's running forever, this inventory server.start function is being ran in here. If the inventory start function never finishes, then if we ever add anything else here, like maybe we have another system, we're going to maybe do shop server.start or something, then this will never actually run because this will never finish. So we're going to make sure before we do an infinite while loop, we're going to do a test.spawn. And then we're going to do our while loop. And here's where we're going to need to define the interval to wait between doing autosaves. So I'm going to create some variables up here, or a variable. And I'm putting it in all caps because that's just the standard way to create a constant variable. Constant meaning the variable is never going to change. And so by having these in all caps, it signifies that this is a variable that's never going to change and that we can modify at the top of the script here. And this is just going to be 2 minutes, so it's 60 seconds times 2. You could change it to 5 minutes, 3 minutes, whatever you wanted. For testing, I might actually put it at 15 seconds. And what we could do, one way we could do this, is do task.wait, autosave time, and then we could loop through all the players and then do inventory server.save data player. And this will save the data for every player in the game every 15 seconds or however long this is. But the issue is that it saves the data for every player at the same time. And the issue with data stores, which is what we're going to be using to save and load data, is that if you do too much with a data store at the same at one time, then it'll kind of give you issues because they're essentially rate limited, so that way you can't save or load too much data at a specific, like in a specific interval. So what I found that works really well with this sort of autosave system is instead of like waiting the autosave time and then just looping through all the players, is to actually wait a fraction of the autosave time in between each player's data being saved. So what we're going to do is we're going to remove that wait, and then we're going to add a wait in here, task.wait, and we're going to wait for autosave time divided by number of players get players. And that'll wait essentially, so say our autosave time was like 3 minutes, right? And there's 5 players in the game. So this is going to run, it's going to do the while true, and it's going to loop through those 5 players. For each of those 5 players, it's going to do autosave time divided by the number of players, which is going to be 5. So it's going to do a fifth of the autosave time. It's going to wait for a fifth of this time, and then it's going to save one player's data. And then it's going to wait a fifth of this time and save another player's data. And it's going to wait a fifth of this time and save another player's data. And that way, it's evenly spacing out the saving of each player's data, while also still giving each individual player about this amount of an autosave time. So each individual player still gets a 3-minute autosave time, but it does it it spaces the autosaves out rather than doing it all at once. In order to test this, I'm going to put this back to 15 seconds. We already have these prints in here, so those will let us know if it's running it right or not. And we can go over here to test. We can create a local server, which will let us run multiple, essentially, test players on the same computer. So I'm going to do I'll do 2 players. Actually, I'll do 3 players. Let's test someone that's on my computer. And this will essentially create like a custom server on your own computer and it'll open multiple different Roblox Studio instances that are all testing in that server, which will allow you to essentially, it's like a team test, but if you don't have a team. And so now you can see we have the inventory remake, the base plate right here, the place where we're working at. We have the server, which is a new window it opened, and this is the server side of our little simulation. We can see we have our 3 players there. We can move around, we can do stuff on the server side. And then we have one window for each player. So I'm going to move all those players over so you guys can see them. I think they're all over, yeah. Okay. So now we can play with each player. We can move them around and make them do stuff. Sadly, we can't really control them all at the same time because it's on one computer. But we can look in the output on the server and we can see a bunch of errors, which is exactly what we wanted to do. I'm just kidding. Let's see. So it's giving us a script timeout error. So I wonder if this isn't waiting properly. Maybe, okay, I think I know what's going on. So we're going to go, this cleanup button is always very finicky. The thing I've learned is you go to the server and then press cleanup on the server and it'll close everything all at once. If you press on the players, it only cleans up that player. It's kind of weird. Anyway, so we're going to need to do a task.wait right here. And the reason being, when the server first starts, there are 0 players, and so it tries to wait right here, or it loops, it runs this while loop, and it tries to loop through the players, but there's no players to loop through, and so it skips over this task.wait and ends up just running this while true do at infinite speed, or as fast as it can, and it ends up giving that script timeout error we got earlier. But if we have this task.wait here, it won't affect the autosave time much because it's like a 0.03 second wait, or maybe 0.015 I think, but it will make sure it doesn't do that. Kind of hard to see with this inventory here, but we'll fix that when we get to the client side. But if we go to the server, we can see it no longer has those prints. And I think it should start printing. Yeah, saving has not been set up yet. I probably should have added a print to show which player is saving. But each one of these is for each individual player. So it just finished saving for all 3 players. And now it's going to go back to the first player again, and then to the second player, and then the third player, and then back to the first one. but I probably should have printed the names so that way we could see, because it has like player 1, player 2, player 3. But anyway, you get the idea. Okay, so back to setting up the system. We're going to remove this print, and then there's one thing I forgot to do here. We're going to want to add a new janitor chore right here. Janitor chore function, and we're just going to do it on the same line, just because there's not really any reason to do 3 lines. Inventory server dot all inventories player equals nil. So that way, whenever the player leaves the game, it's going to take their inventory data and it's going to remove it from the all inventories table. Because otherwise, as players join and leave and join and leave on that same server, it's going to add more and more data to this all inventories table, and it's going to essentially create a memory leak that's going to make the server slower and slower as it gets older. So this will help prevent that a little bit. And then we're going to want to set up, so we have the save data set up. I mean, it's not going to save anything, but it runs whenever we need to run. It runs when the player leaves, or it runs when the server shuts down, and it runs on this autosave loop. Speaking of which, I'm going to change that to 3 minutes. But we don't have this load data function being run anywhere. And where we're going to run that is right after the player's character loads in, because that's when the backpack is going to be created. So we're going to run this function, or we're going to run this line. It's just an if statement. So if player.character, the character is a property of a player. So if I go up here, you can see my player, go to properties. Right here, character. Right now it's not set to anything because I'm not in the game right now. But whenever your character loads in, it sets this property as a reference to your character model. So we're going to check if that reference has been created, essentially if the character has been loaded, and if it hasn't, then we're going to wait until the character is loaded. Otherwise, it won't do anything because the character is already loaded. So then we're going to do inventory server .load data player, and that's going to load the data after the first time the player spawns in. And then just to test that, we can hit play, and loading has not been set up yet. Cool. So then, one final thing we're going to do is we're going to set up a function for when the player's character spawns in. Instead of defining a function separately like we have here, we're going to define it inside this onPlayerAdded function, because we're going to need to reference some of the same variables like the inventory and everything. So we're going to do character added local function char added char, and this parameter is going to be a model because it's the player's character model. And we're going to do connecting character added, and we're going to do if player. Actually, we don't even need to do if player.character because we already know the player's character is already loaded because we just waited for it to load. So we're going to do instead char added player.character, and then we're actually going to put that in task.spawn as well, just in case this has a delay, this function. Task.spawn char added player.character, and then player.character added connect char added, and that'll account for when the player respawns, and it'll run this function again. So we're gonna add this print test, and it'll print whenever the player like spawns in the game or respawns after they die. And then if we test this, you can see 1919 has spawned. If I reset, it says I spawned again. One issue with this, however, is that there's this weird issue with players in Roblox, in the Roblox game engine, Roblox Studio game engine, and it's that whenever you leave the game, your player object is never fully destroyed. And I think there's some technical reason why they haven't been able to fix that, because there's like issues it would cause if they did completely destroy it. But as a result, that means when you connect to events like player.character added, if you destroy the player, or like if the player leaves the game, this event will not disconnect. And so the computer's still going to be listening to that event even though that player's already left the game. And so it causes this weird issue where it's just essentially just a memory leak, and it can lead to build up lag as the server gets older and older. So what we can do to fix that is just disconnect this event whenever the player leaves the game. One thing that will make that really easy to do is using our janitor, the object that we created. So we can do janitor give chore and just wrap this whole thing in that. Because this, the player.character added this connect function, when you run connect on an event, this whole thing will return the connection. If we put that connection in the give chore function of the janitor, then when the janitor runs the chore, you can see Roblox scope connection, it'll disconnect that connection. And so then it'll automatically disconnect the connection whenever we leave the game, which will help with that memory leak issue I was talking about. Alright, so I think that's going to be the end of this episode. We didn't get to do a whole lot of there's not a lot of visible results yet, because so far it's mostly just been preparation work. But in the next episode, we should get further into the setup of the actual inventory. We're going to be working on a register and unregister function in order to create the stacks inside the inventory that will actually hold the information for each stack and whatnot. But this episode is running a bit long, so I'm going to end the episode here. If you guys are interested in purchasing any of the completed files or any of my tutorials, then you can always buy the membership program on either YouTube or Patreon. It's for $2.99 a month. You can additionally purchase the higher 2 membership tiers, which both include personal tutoring online on Discord or whatever other platform you communicate on, where I can help you one-on-one with your projects and help you learn whatever you want to learn. Either way though, thank you for watching this second episode of this series, and I hope you enjoyed, and I'll see you guys next time.